So yesterday we learned a normal distribution curve, which is a bell curve. Okay, so standard bell curve, these are the z-scores laid out instead of the actual scores. Now what you need to know, and this is in the formula sheet, all the scores between z-score of 1 to -1, 68% of the scores, or approximately, lie within that graph. Okay, that's just a fact. Now, when we get to z-score between -2 and 2, about 95% of all the scores lie in that range in a normal distribution curve. And between -3 and 3, about 99.7% of all the scores lie between 3 and -3. Okay, and the rest, or whatever scores left outwards, would make up to 100%. Okay, this is in your formula sheet. Now the bit that I'm going to show you is not in the formula sheet, and I need you girls to memorize the numbers I'm about to write here, just to make your life easier with exercises. Girls, if I was to cut the 68 in half, that would be 34% on both sides. Yep. Now, when it comes to this bit, if I do 95, take away 68, divide by 2 for the remainder, you're going to get 13.5% on both sides here. Okay. Oops. And for this section here, what do I need to do? 99.7. Take away 95, divide by 2, you're going to get 2.35%. Okay, and lastly, whatever's outside to make up to 100% is actually 0.15%. Okay, I know these numbers are quite, tedious and long, but it'll make your exercise and exam life so much easier if you just memorize these numbers. Okay, and you'll see why. Let's have a look at example 15b to illustrate that. So girls, a normal distribution has, what's that symbol, 65.2? That's the mean, and standard deviation of 1.3. If the question asks you what percentage of scores lie between, as soon as you see the word what percentage, the first thing you want to do is always draw a bell curve like that and set it out like I did there. So let's put the mean here. What's the mean? Sorry. Okay, and it's going up by the standard deviation, yeah? So I'm just going to write down the answers. All right, so I'm just adding the standard deviation here, taking away the standard deviation on this side. So once you've done that, girls, look at the question. What percentage of the scores lie between 61.3, so that's from here, to 65.2? That's all the way, that's in the center, isn't it? Okay? So to calculate that, just use all those numbers there. Okay? So basically, yeah, you're just adding 34% plus 13.5% plus 2.35%. If you add them up, you'll get your answer. I don't know what it is. Okay? Yeah. All right, let's have a look at the second part. This is first part. Listening, please. What's the question? 65.2. So once again, from here, and then to 66.5. Oh, that's not hard. That's just 34%. Okay? And the last part, just to wrap it up, what do they want us to do from? 62.6. That's from here to all the way at the end. So up to here. So that plus that plus that plus 13.5 plus 2.35%. You get 97.35%. Okay? So like I said, if you memorize these numbers or have it handy next to you, it's just a lot easier to work with rather than fiddling around with those numbers. That's basically your first exercise, so which we're now going to move on to the second part. No, I can still squeeze things in. Okay. Now, so this is exercise 1406, empirical rule. Now, the second last exercise for this topic is actually just using the z-score formula, and that's in your formula sheet. So you know what these symbols are, but just to illustrate, that's the actual score, or some say raw score, the actual score itself. That's the mean, and that's the standard deviation. And you can see that this formula is actually the case. It's true, because for example, like from here, let's say. So what z-score does that have, if that's the mean? It's 1, right? It's 1 standard deviation away from the mean, so that has a z-score of 1. So in fact, if you plug it into this formula here, so that's the raw score, 66.5, take away the mean, which is 65.2, and you divide by the standard deviation, which in this question was, I think, like
1.3.
Yeah, 1.3, you get 1. Okay, so it makes sense. You're just taking away the difference between the score and from the mean, divided by the standard deviation, which gives you the z-score. So it's not a fancy formula. It's just, that's just how it is. If you calculate it, it works out. So let's have a look at example 17 to now illustrate that. Okay, fine. Let me just look at the question. Find the z-score for each raw score. Okay, so if you just find the z-score, just use the formula. Okay? So find the z-score for AI. What does that represent? What does that represent? What does it say in the question? Find the z-score for each raw score. So, what's the number there? 23.5?
Yeah. Oh, what?
No? 25.7, sorry. I'm not awake yet. What?
Why should what?
I made a mistake. What's the mean? Oh, it's right there. And what's the standard deviation given?
1.2.
Okay. And that will give the answer, which is, okay, sorry for wasting your time, but you get the point.
Yeah.
Yeah. No, but there's more to it. Just hold on. I'm not done. I picked this example for a reason. Okay? So that's 1.58. Oh, and it also says, girls, please read the question carefully. What does it say in the question after? Describe radius on the standard normal distribution. So if a z-score of 1.58, what does that indicate? Well, this is where z-score of 1 is, yeah? This is where z-score of 2 is, so it's about there. So if you look at the description, it just basically says, you just have to say a score of that lies 1.58 standard deviations above to the right of the mean. Just describe where it stands from the mean. Yeah, so just read the question carefully. Okay, now, skipping on. So, girls, for the second part, if you do the same thing, the z-score is -2. I'm just writing the answers here because I want to get to the second part of the question. Z-score for the third one is 3.75. Okay. Now, look at this part of the question here. Which of the scores from part A are very unlikely? Given these z-scores, which one of these scores is very unlikely is the question. So the question you need to ask, so basically the answer is, if you think it's actually triple I. Why? It is. 3.75 is like all the way, the z-score is like all the way up here, isn't it? The further it is away from the mean, the more unlikely it is. Yeah, that's all it is. Furthest. All right, now, just last example to illustrate it. Sometimes, girls, for example C, girls, please stay with me. You got to work backwards as well. Find the actual score with the z-score of -1.82. So from the formula, we got to work backwards. That's 1 minus, you get the point. We need to find the score. We know the mean. That's 23.8. We know the standard deviation, which is, is it 1.2? Yeah, you know how to do that. Yeah? So if you do that, where's the answer? There you go, 21.62. Okay. Girls, are we good with working backwards? One last question, but I just saw a good example from standard maths as well that advanced didn't. Where is z-scores actually used besides like analyzing data like this? On basic level, this is where it will be used. Have a look. I don't know if you guys can see that. Let me just zoom it in more. Let's make it 120%. So, girls, Xavier scored 65% in the English test. Now, let's not look at what's inside the bracket. On the surface, girls, on the surface, someone scored 65% in English and 61% in mathematics. You would think he did better in English because the mark's higher, right? But that's not necessarily the case. It depends on how the class did, which is the average, and the standard deviation, so in other words, how far overall those scores were from the mean. So this is where z-scores are used, okay? So if that's the actual score, that's the mean standard deviation, plug it into the z-score formula. So for English, the z-score is 1.37 for that student's English subject, okay? If you do the same thing for maths, because it's got different mean and standard deviation, obviously, for a different subject, the z-score is 1.87. So even though the mark in his English was higher, doesn't mean he did better in English because in comparison to the class where he stands, he did better in maths because his z-score is higher, which means it's further away from the mean. To the right, obviously. If that was obviously negative, that means he did below the mean. Yeah? So the z-score, higher it is, indicates how well you did within that subject. It's not necessarily just based on raw score, it's on the mean and the average, the standard deviation. Does that make sense? Just wanted to show you how it's related. All right, that's it from me, girls. Do those two exercises, all of the questions. Thanks.